Welcome to my channel. Today we are going to start a new topic of this chapter, which is electric dipole. So electric dipole basically a system which consists of two equal and opposite point charges. Let's consider two point charges Q and Q. Both are having same magnitude, but nature of these two charges should be different. So first charge is plus Q and second charge is minus Q, and these 2 point charges are separated by a small distance. Let's consider 2a. So this arrangement is known as electric dipole. So electric dipole is basically a system that consists of two equal charges having same magnitude but opposite in nature, and these two charges should be separated by a small distance. And separation between these 2 point charges, which is 2a, this 2a is known as dipole length, which is a vector quantity, and direction of this dipole length is always from negative charge to positive charge. Negative to positive charge. And what will be the strength of this electric dipole moment? This can be measured in terms of dipole moment, which is known as electric dipole moment. Electric dipole moment. So electric dipole moment basically measure strength of electric dipole, which is defined as product of either charge and separation between these two charges, which is known as dipole length. Product of these two quantity is known as electric dipole moment. So either charge, magnitude of either charge Q, and separation between these two is 2a. So Q into 2a is known as, product of Q into 2a is known as electric dipole moment, which is represented by P, and this electric dipole moment is also a vector quantity. And what will be the direction? This P is directly proportional to the dipole length, which is a vector quantity, and direction of this dipole length is always from negative charge to positive charge. Therefore, direction of this dipole moment will be also from negative charge to positive charge. And what will be the unit of this quantity, dipole moment? Unit of dipole moment, which is given by Q into 2a. Charge, which is measured in terms of coulomb, and a separation in a meter. So coulomb meter will be unit of this dipole moment, and dimension of dipole moment. Charge, dimension of charge is 80, and next one, length, dimension of length is L. So dimension of dipole moment will be ATL. Dimension of electric dipole moment will be ATL. So Now we can find electric field of a dipole. So how to find electric field due to a dipole? So there may be two possibility. First one, the field of a dipole at a point on its axis, or this special case is also known as on axial line. Okay. So let's consider that electric dipole which consists of two charges minus q and plus q, and the separation, let's consider at point A minus q charge is placed and at point B plus q charge is placed, and these two charges are separated by a small distance 2a, and point O is a center of this dipole. So if O is a center of this dipole, so this 2a will be divided into two equal parts. So A to O will be equal to A, and O to B, this one will be also equal to B. And according to this heading, we have to find electric field intensity due to this arrangement at a point on its axis. So let's consider that point of observation lies on this axis, and that point is P. We have to find electric field intensity due to this arrangement at this point P. So distance of that point of observation, which is P, from center of this dipole is R. Okay, so in previous lecture we have discussed electric field due to a point charge is equal to 1 upon 4 pi epsilon naught q by r square. Means a single charge can produce electric field, but in this arrangement how many charges we have? Two charge. So this minus q charge will also produce electric field at point P, as well as this plus q charge will also produce electric field at point P. So let me find electric field produced by these two charges. First, electric field produced by minus q charge at which point? At point P. So expression, let's consider notation of this electric field due to this negative charge is E minus. E minus is equal to 1 upon 4 pi epsilon naught, magnitude of that charge is q, and distance, square of the distance between charge and point of observation, which is, that is, distance will be AP square. And what will be the AP square from this diagram? R plus A. So E minus is equal to 1 upon 4 pi epsilon naught q upon AP. AP from this diagram, it is clear that AP will be equal to R plus A whole square. Equation number 1. And let me mention direction of this electric field. Due to this electric field, because source charge is negative, so due to negative charge, electric field, direction of electric field produced by that negative charge will be always towards source charge. So direction of electric field produced by this negative charge at this point will be towards negative charge. So this represent direction of electric field produced by this negative charge. And come to the next one. what will be the magnitude and direction of electric field produced by this plus q charge? So electric field produced by plus q charge at point P, and notation of that field is E plus. E plus is equal to 1 upon 4 pi epsilon naught, magnitude of that charge q, and distance between source charge and point of observation, that is BP square. So E plus is equal to 1 upon 4 pi epsilon naught q, and BP, what will be the numerical value of BP from this diagram? It will be equal to R minus A whole square, equation number 2. And direction of electric field produced by this plus q charge, which is a positive, will be always radially outward. So electric field produced by this plus q charge will be radially outward. E plus, you can mention direction of these two quantity, direction along, due to this negative charge, P to A, along P to A, and direction of this E plus B to P, along B to P. So finally, how many charges, how many electric field intensity we have got at that point of observation at P? Just look at this diagram, 2, E minus and E plus, and direction of these two vector quantity are just opposite to each other. So we can find resultant electric field intensity. So net electric field at point P E, and this special case is what? Axial case. So net electric field which is axial, E axial is equal to, according to law of parallelogram, if two vectors acting just opposite to each other, so resultant will be equal to difference of these two vector quantity. So means how to get resultant here? In this case, just subtract these two quantity, and subtraction will be always from higher value minus lower value. So which one is a higher value, equation number 1 or equation number 2? E is inversely proportional to R plus A, means R plus A, sum of these two quantity will increase. So due to this increasing value, electric field intensity E minus will be reduced, and here R minus E, which is a less. So due to this less value, E plus will be greater, that means E plus will be greater than E minus. So resultant electric field will be E plus minus E minus. Now put all these values. E plus 1 upon 4 pi epsilon naught q R minus A whole square minus 1 upon 4 pi epsilon naught q upon R plus A whole square. So in these two terms we can take common q upon 4 pi epsilon naught. So in bracket R minus A whole square minus 1 upon R plus A whole square. So q upon 4 pi epsilon naught. Now LCM of these two quantity, R minus A whole square into R plus A whole square. This one will be equal to r plus a whole square minus r minus a whole square. Now simplify. So final expression E, last expression which we have got, E axial is equal to Q upon 4 pi epsilon naught. This one. If we solve this expression, a square minus b square, so it will be equal to r plus a plus r minus a, means simply a square minus b square, a plus b into a minus b, r plus a minus r plus a, upon this one will be equal to r square minus a square whole square. So plus a minus a cancel out, and in second term plus r minus r cancel out. So q upon 4 pi epsilon naught, in first bracket it will be 2r and second bracket it will be 2a upon r square minus a square whole square. Okay. And this can be written as, if we modify, if we rearrange this equation, so this can be written as 2r into q into 2a upon 4 pi epsilon naught r square minus a square whole square. Since q into 2a is nothing but dipole moment, so this quantity q multiplied by 2a can be replaced by electric dipole moment. So E axial is equal to 2r upon 4 pi epsilon naught p upon r square minus a square whole square. And suppose a special case, case number 1, if this point, if point P, which is the observation point, is very close to this point B, then if, or another case, if point of observation, that means that point, if this P point P is much away from this dipole, means R is much greater than this dipole. So in this case E axial will be equal to 2r upon 4 pi epsilon naught dipole moment upon, due to this small value of a, we have to ignore this value of a, so you will get only r square whole square, 1 power of r will be cancelled out. E axial is equal to 1 upon 4 pi epsilon naught p upon r